So if you're getting into reloading, or perhaps you're a seasoned reloader, there's a lot of information out there that could perhaps be misleading onto what to do for your rifle and how to get the best performance. It seems like every month we're introduced a new product claiming to be the best and claiming to have all of this technology involved with their product to give you the best performance out of your rifle. So you can spend anywhere between $60 to $400 on a full-length size and die. And I'm not going to discredit those companies out in the market. They obviously make a great product, but I really want to emphasize in this video exactly what you're paying for. So if you're paying $400 on a full-length size and die, is that necessarily giving you the better performance? Well, today's video, we're going to talk about just that. I'm going to showcase basically some of the dies that I've been making and kind of give you guys the information about what a full-length size and die should be doing, and if your money is better invested elsewhere. My name is Kenny, and you're going to like this video. So the topic of reloading in general is a pretty tough topic to talk about, especially here on YouTube, when YouTube has specific policies infringing our rights per se, that we can't show the manufacturing process of ammunition. On YouTube's eyes, they think that showing the process of reloading is blasphemy and will end the human race as we know it. And if you're a manual YouTube reviewer watching this video is simply not that. I am not showing the process of manufacturing ammunition. I'm simply showcasing some of the tools that I make. Though it is part of the tools in aiding in manufacturing ammunition, it is not showing the whole process, thus complies with our guidelines. With that said, reloading in general as a topic seems to bring out some of the most saltiest commenters out there here on YouTube. So if you're one of those soft-skinned individuals that have no sense of refrainment to hold back your heavy opinions in the comment section and want to be a butt nugget and comment something nasty, I'm simply just going to block you from the channel. So I'm going to ask you guys to be respectful. As a community, I think we could do a lot better as a reloading community. We're all here to learn. There's much knowledge out there to share, and we could do this in a polite manner. So with that said, I'm definitely going to state I'm not a pro at any of this, and I don't need to put pro in my name. However, I am a rifle manufacturer that has produced a lot of competition rifles, and based off my experience building competition rifles as well as competition reloading dies, I can share that experience with you guys. So for demonstration purposes, what I have in front of you are some custom 6mm Creedmoor dies that I've made in the past, as well as a factory L.E. Wilson 6mm Creedmoor die that was sent to me by a client, along with some of his reloads and his rifle. Now, these two pieces of brass are once fired. Now, actually, this one is twice fired now, and then this is once fired and reloaded. They're both Peterson brass small rifle primer and reloaded with a 105 hybrid and around 42.5 grains of 4350. Typical target load that most 6 Creedmoor shooters use. Now, what we were finding downrange with this rifle that was sent to me for evaluation was he was getting all kinds of flyers, really high SDs, and it actually had a case head separation with a factory loaded cartridge. Essentially went out to a match, bought some Hornady match ammo, and just had all kinds of issues. So he sent me this rifle to see what's going on, and obviously taking precaution, I did a couple test fires myself and also confirmed what he was seeing downrange. Now, like I said, these are both fired pieces of brass. This one is twice fired, this one is once fired and reloaded. And according to the SAAMI measurements for a 6mm Creedmoor, the bottom of the case, which this was resized and using the L.E. Wilson die, should be around 470 thou. So we're seeing 469 thou and 910 thou, so essentially 470 thou. And we should see about 462 just underneath the shoulder area. So we're getting around 462 and 810 thou. So essentially this full-length size and die was resizing the case correctly back down to SAAMI minimum spec in the drawing. However, when this was fired on that custom rifle that was chambered by a different shop, which I won't name, you'll see that the measurements both at the case neck are significantly more. 464 and 410 thou right under the shoulder, and at the base we're getting 474.1. So significantly more, taking the fact that the cartridge itself is supposed to be size 470. So this one's expanding around 4 thou, and on top around 3 or 4 thou as well, significantly making this cartridge pretty much blow out quite a bit. Hence the reason why he possibly had, or probably had, a case head separation and the flyers that we're seeing downrange. So with that said, how do we essentially fix this issue? Well, the only way to fix this issue, to continue using that barrel, is to basically send out these cases that are fired, I'd say twice fired, to a custom die manufacturer such as Wood and Gun Works, in which they can make a full-length size and die to match the dimensions of the fired case. Now, that's a very expensive process and also takes a lot of time. Or do we just go ahead and rebarrel the rifle and chamber it correctly with a proper chamber and get the dimensions of that chamber closer to what the full-length size and die does? And that's essentially what we did here. So essentially what I ended up doing was rebarreling the rifle and made a 6 Creedmoor full-length size and die. So commercially available dies like this in the market are typically made out of 416R stainless steel, either 17-4 or perhaps tool steel, or they will have some kind of coating on there like nitride to increase the surface hardness to help mitigate marring and scuffing of the brass when resizing. Now, the dimensions inside the full-length size and die itself are all standardized if the cartridge is a SAAMI spec cartridge. What I mean by standardized is that they use the measurements off a SAAMI spec print. And if you're not familiar with SAAMI is, S-A-A-M-I, that is Sporting Arms Ammunition Manufacturers Institute. In short summary, what a SAAMI drawing is a specific dimension that is standardized for manufacturers like me to be able to build a rifle barrel and use specific measurements that are ground, like a chamber reamer, and also build ammunition. That way we don't blow our faces off. It's a way to keep us safe, essentially. So, reloading dies in general are either a single point cut on a CNC lathe, which means they have a micro boring bar which will go in there, cut out the dimensions, and then they send it out for either nitride coating or surface hardening. Or they use a reamer that is very similar to a chamber reamer. Now, this is the process that I use. I have a finishing reamer, this is in a 6mm GT, and I have a resizing reamer, which is the same dimensions as the chamber reamer, except it's undersized 2 thou. So that 2 thou difference in measurement is going to help with the brass spring back and also give you the best fitment of the brass. Now, this is best case scenario given the fact that the chamber of the barrel itself was chambered in a way that it doesn't induce any other variables and measurements, such as a floating reamer holder. Now, that is one of the problems with a factory rifle. Factory rifles are done in a way of high production, and so there's compromises being made for the precision aspect of things. When a reamer like this goes into a chamber, more than likely they're using a floating reamer holder, and if you don't center the bore of the rifle barrel as meticulous as much as possible within 1/10 thou, then any kind of deflection towards the back will start cutting the chamber wider in the back versus the front, which will give you a loose fitted chamber. Hence why this piece of brass right here is measuring a lot larger than my full-length size and die gives on this piece of brass. So when considering the precision aspect of things on reloads, you really want the best fitment of brass as much as possible. Hence the reason why I make my own dies, which are based around my chamber reamers that I have. So guys that are looking for the best possible performance out of their rifle, I will chamber their rifle on a solid reamer holder and get the best measurement as much as possible. The measurements on the chamber itself typically do not deflect more than 1/10 thou, from what I could see from Sarah Casting. And then the same process is being done when making the actual full-length size and die, except I use a sizing reamer, which is size 2 thou under. So let's go ahead, let's show you guys the process of what I'm doing. I'm building this 6mm arc full-length size and die, kind of give you guys an idea. You know, I did a video on the past how I built some of these dies, but I've since revamped my process. I'm using now a bore-through flush system, and obviously I got some better tooling now. So let's go ahead and let's show you guys what I'm doing. Okay, so I have the die set up. I have my 6-arc sizing reamer ready to go. I have a solid reamer holder and the bore through flush system. Now it is a little bit loud. I'm gonna go ahead and turn it on. And I'm gonna get the fluid flowing through the actual die itself. Now we're gonna turn the lathe on. So we're gonna go ahead and ream this until I get about 128 thousandths protrusion using a go gauge. All right, we'll go ahead and stop the lathe, clear out some of the chips. And continue on. Okay, so I just finished up reaming this die, and this is a Dave Manson go gauge. The protrusion I have on this, on the go gauge, is 127 thou, and the measurement that I'm taking for that is basically getting one of my Reading competition dies, and you see that's 124 thou or 125. So I got about 2 thousandths of bump for spring back. By using the Reading competition dies, you could have them as -1 thou more bump or up to -4 thou. And then obviously the chamber itself, if you guys seen it, there is a open area for putting a bushing in there. So the reamer I have spec'd out in the 6-arc, this is a Dave Manson reamer, sizing reamer. The actual measurements on the neck itself are actually perfect. You don't necessarily need to use a bushing. However, this client specifically wanted to use bushings, so essentially what I did is kind of hybrid the system where it is going to give you the best fitment of my chamber near the actual shoulder. There's a little bit of a lip, so I'll give a kind of a false shoulder per se. And then if you wanted to use more neck tension, it will be more neck tension towards the top of the case mouth. So all I'm going to do now is put a chamfer on that die itself, polish it up with 4/0 steel wool, and then give it a test before sending it out to nitride coating. Before we send this die off to nitride coating, let's do a quick little function check. I got a couple pieces of brass that was shot out of my Cobalt Kinetics, very similar to the dimensions of my chamber reamer that we're going to build a rifle for this client. But the bottom of the case here is measuring 439 thousandths and 4/10 thou. Let's give a quick little resize here using some lube. And before we do all that, let's get a comparator measurement to make sure we are bumping this brass back a little bit if possible. So that's right at 0. Put this up here and let's see what this die does. Now it might mar the brass a little bit just because it doesn't have the nitride coating, but everything seems to feel pretty smooth. It did bump back the brass about 5 thou, so that's a good sign there. And the measurement on the base, we want to make sure this folding sizing die is sizing the case all the way down, is showing 239 thou. So very tight tolerances, and this die is doing pretty good, exactly what I wanted to do for measurements. So there's definitely a big advantage being able to make your own reloading dies, including a bullet seating die like this one. Now this one was made very similar, except I used the same chambering reamer that I used for building the actual chambers of the rifle, and this one does have a Mitutoyo gauge on top of it. Now these dies are also available on NewlandPrecision.com. He's a small business owner there in California that also makes dies like this with the same kind of Mitutoyo gauge, and also makes die blanks. But being able to make your own dies to have it best fitted for the rifle is a huge advantage and helps you build ammunition that is very consistent. Now being able to produce ammunition as consistent as this obviously is going to aid in the accuracy downrange. Now this cartridge that we just put together, it being once fired brass, is showing about 2 to 3/10 thou of run out, which is very, very good given the fact that this is once fired and we put it through the reloading die that we just built. So I'm going to close out this video with some food for thought and a question for you guys. Do we necessarily need to be spending all of this money on really high-end reloading gear? Do we need to drop money on an Area 419 press, perhaps spend $600 on a short action custom die set, or do we need to get on a wait list for a Prometheus powder measure? Just to get the performance that we're trying to gain downrange, when 90% of the shooters out there are typical target shooters or plinkers trying to hit an MOA target at 1,000 yards. Is there money to be invested elsewhere to get that kind of performance? Maybe somebody knows how to build one of these, a barrel. Now, I showcase a lot of this on my channel, showcasing basically what a quality barrel does and a good chamber job on a production rifle, and kind of accuracy you get, and as well as how less picky it is with the ammunition. Now, obviously I went down that rabbit hole, as you can see, buying all of this reloading gear, and through my endeavors over the last 10 years collecting this stuff, there's a lot of reloading stuff that I'd never use, and I spent a lot of money. So videos like this, I think, really help kind of understand exactly what you're doing for reloading. And when you're considering a reloading die, manufacturers like Redding, RCBS, Lee Precision, Hornady, the truth is that these reloading dies are actually pretty good. From my testing on the lathe to see the kind of run out, pretty much these dies run around 1 to 2 thousandths of run out, which is very good for making good precision ammunition. Now, if you're buying dies out there that are claiming to have the best run out and all of this stuff, you got to remember these dies are meant to size the cases down to a specific measurement unless they're spec'd out for the chamber of your rifle. So dies out there that have all these coatings and claiming saying the most minimum run out there, the easiest extraction and the best reloading folding size and die out there, you're really getting sold if you're not understanding exactly what kind of die you need for the rifle you have. So if you have a production rifle with a sloppy chamber like this one, and you have a reloading die that you're using that is high end and is sizing the cases down like it's supposed to, but your chamber is sloppy, you're pretty much hurting yourself for accuracy and not gaining any kind of performance. Well, that's all I got for you folks. Thanks for watching. I'll catch you guys in the next video.